We've made it to the algebraic ones. These are the ones we have the most practice with because they're the easiest for us to do when we're at the boards. Our very first question is our chain rule where we have the ln of stuff. So if we were going to find y prime here, we know that the derivative of ln of stuff is 1 over our stuff. But we also need to remember that since we have stuff, we need to take the derivative of that. So we have 2x minus 4. This answer is perfectly fine. A cuter version of it would be to have the 2x minus 4 over our x squared minus 4x minus 7. Boom, done. All right. Since that was short, let's go ahead and do number 9 in the same video. Number 9, we are taking the derivative of what looks like a quotient and chain rule combined. So that's what I could see a lot of students doing here. I will go ahead and do that. But first, I'm going to do it the way I would do it. So if I look at this question, I see my d dx. The thing I want to take the derivative of here is really just a 1/4 times this x minus 2 to the negative 3. So I've taken what was a pretty gross looking chain rule question and I've changed it. It's still a chain rule question, but now at least it's a power rule with the chain rule as opposed to a quotient rule with a chain rule. And we'll find out that the chain really doesn't matter here. So if we take the derivative, we have our constant multiple out in front. We're going to bring down that negative 3. I'm going to move this one slow. Times x minus 2. Negative 3 minus 1 is negative 4. And then if we go to take the derivative of x minus 2, that inside function, we just have a 1 as our derivative. So that was a little bit silly, but at least saved us from possibly making mistakes somewhere. So here is the answer to our question number 9. And if we want to make it cute, it's negative 3 over 4 times this x minus 2 to the 4th. Now, if we had done this with the quotient rule, right? If we had not recognized that we could indeed power rule this after a little rewrite, then we would have been over here. Bloop. We got, okay, low, d high, O, minus high, d low, so that'll be a 12, right? Because the 3 times 4, x minus 2 to the 2nd times a 1, all over 4x minus 2 cubed. Oh, that's ugly looking. All of that squared. So obviously leaving it like this is not great, especially because it says simplify your answer. So we should get rid of some stuff. We end up with a negative 12 x minus 2 squared. That's just this term right here. There was a bunch of ones that didn't matter, so let's just get rid of those. And then the square applies to both factors here. So we have a 16 x minus 2 to the 6th. When you raise something with an exponent to another exponent, that's where we end up. And then this can simplify. Both 12 and 16 are divisible by 4. So this could go down to 3 over 4. And oh, these are the same, different bases, so we can rewrite this as just x minus 2 to the 4th. So again, either of these are acceptable as simplified. I don't necessarily care about positive exponents, but it would have taken a little bit more work to simplify if you had moved through the quotient rule.